Thank you very much. I'm very glad to be here for to Dr. Akor for this. It's a fantastic introduction to what I want to talk about today. So let's put up my slides. I think you're seeing them, right? Okay. So what I'm gonna talk is about this concept of genetically determined AD, which, by the way, this is a concept that we coined to introduce Down syndrome as within the family of genetically determined AD. And in the paper that I'm gonna mainly talk about today this concept that maybe APOE4 homozygotes should be also included in this family. So these are my disclosures. So I consult for a number of companies developing drugs in this space, in sporadic AD, Down syndrome associated Alzheimer's disease, and also APOE. So let me start with what I'm going to talk about, the outline. And so let's first start with the outline and the consequences. And I think this sentence clearly explains why this paper was so controversial. Because as Dr. Ashford has mentioned, this APOE has been recognized as the main genetic factor behind Alzheimer's disease for many decades. But basically, if you look at it this way, we would be saying that if including APOE4 homozygotes in genetically determined AD increases the prevalence of these genetic forms to more than 50% of symptomatic AD, from far less than 1% if we only consider autosomal dominant AD. And that means that more than 15% of the cases, the cause will be clearly identified in just one genetic factor. And this, of course, has generated a lot of controversy. So what I'm going to structure my talk is first showing the evidence supporting that APOE for homozygotes indeed should be considered as a distinct form. So basically, I'll review the paper. Then I will signal some areas of controversy around it and some work that, in my mind, needs to be done, and acknowledge that there is a controversy here. And certainly, I would like to end up with a call for action and reasons for being optimistic, because I truly think there are many reasons to be optimistic and to prioritize homozygotes in prevention, therapeutic trials, and more research in APOE. So let's start with the genetic architecture. This is the kind of slides that you would see in all the conference for Alzheimer's disease, and tries to summarize the genetic architecture of the disease. And here what you're seeing is two axes. So in the x-axis, you are seeing the frequency of the different genes or mutations, if you will. And so the more to the right that you're here, the more frequent this genetic factor is in the population. And in the y-axis, we depict the risk that these genetic forms, these mutations or these variants confer for Alzheimer's disease. And here I would like to say that details matters, and these axes are broken. And are broken here in the x-axis, saying that this is more or less frequent, and this is rare, very, very rare. And the same here in the y-axis, denoting something that is causal and something that is only a risk factor. And so here we end up having this very small proportion of cases. This is autosomal dominant AD due to mutations in the presenilin 1, 2, and APP genes that have received a lot of attention, a lot of investment, because they are considered to be causal of Alzheimer's disease. Whereas the rest are considered risk factors, very, very important to understand the pathophysiology, identify targets, but we've been less effective in really targeting those at least in clinical research, and I'd say also clinical trials. And whenever I present this slide, I always say there is an elephant in the room, and that's Down syndrome associated Alzheimer's disease, which I think now we've come over the controversy. I would like to emphasize this and I have a few slides here, but sometimes people don't talk about Down syndrome, and certainly it's a model of genetically determined disease, Alzheimer's disease, and the reason why we coined that. And of course, we're here today to talk about APOE homozygotes. So, and I don't want to play with words, but I think that you also be aware that in order to define what is genetically determined Alzheimer's disease, first we should agree on what is Alzheimer's disease. And here things are not as clear. And I think that in order to put some order into the controversies and to put some rationale here, I think that rules matter. So I think that in science and in sports, rules matter. Why do I say that? Because in Alzheimer's, we still haven't reached unanimous agreement on how to define Alzheimer's disease. This is a slide in which we can see the evolution of all the criteria on how to define Alzheimer's disease. And I would say that today we have two sets of criteria. We have the Alzheimer's Association criteria that were published in 2024 that define the disease as biologically, and the international working group that classifies the disease from a clinical biological perspective. So let me dive a bit more into this concept. This is a crucial difference. Because basically the Alzheimer's Association criteria, which by the way, I must admit that I favor, I'm not saying that the International Working Group don't make valid points, but I think that the Alzheimer's Association criteria define the disease biologically. So basically, they argue that if you have the biology of Alzheimer's disease, and this can be demonstrated in life through biomarkers, basically you do have Alzheimer's disease. Whereas the International Working Group says, no, wait a minute, you need a clinical syndrome in order to define the disease. This is the clinical biological definition. And why is it important? Because it has tremendous implications on the penetrance, on how many people we're talking about. So here is data from the US, and you can see in millions how many people you have with AD dementia or MCI. So the dotted lines, the pink one and the red one, that would be symptomatic Alzheimer's disease. Whereas all these huge curves is if we include people with biomarkers of Alzheimer's disease. So you'll see that we'll discuss several times the penetrance of disease, how much it manifests. It completely changes. It completely changes if we're talking about the biological definition of the disease or if we are talking about the clinical biological definition of the disease. So the first thing when we analyze the data is, are we talking about biology or are we talking about symptoms? And I have to start saying that our paper took and followed the Alzheimer's Association definition, the biological definition of the disease, that does not take into consideration clinical symptoms. However, and more advanced in the talk, I will also give a few words about the clinical symptomatology and the clinical penetrance of the disease. But please bear in mind that when we're discussing one thing, we should state as things, so you cannot support Alzheimer's Association criteria and criticize the reconceptualization of APOE homozygotes based on clinical symptomatology. I think we need internal consistency and being consistent, as we say. We need rules on how to discuss these very important issues that have huge implications, and we all are aware of that. So I'll start by moving into the evidence supporting the APOE4 as a distinct form of Alzheimer's disease and the origin of the proposal. So I would be talking about the Nature Medicine paper and where it came from. And I have to start by saying that this conceptualization comes from a similar reconceptualization that we and others have been doing in the last decades for Down syndrome. There was huge controversy also in the field of Down syndrome, and I think that you will see that now it is widely recognized that that DSAD is a form of Alzheimer's disease. And if you read this paper that we published in 2021, the title is very, very similar. So basically what we are doing in APOE4 homozygotes, what we are proposing is something we propose in people with Down syndrome. And I have to say that, first of all, I am extremely sensitive to the impact that these reconceptualizations have. We've been there with Down syndrome, which is a very vulnerable population, and we are very, very much aware of the impact that these kind of proposals have. But I also have to say that this is the first and necessary step to really increase funding, attention, and research to fight against Alzheimer's. I think that we should follow the data and really move forward to really fight against the disease. So a bit about Down syndrome, and you'll see that what we've been publishing in Down syndrome is something that we did afterwards in APOE for homozygotes. Down syndrome, you all know, is a trisomy of chromosome 21. So instead of having 2 chromosomes of 21, they have 3. And within the chromosome 21, it's located the amyloid precursor protein, this gene. And so if any of you would have 3 copies of this gene, you would develop Alzheimer's disease, no doubt, of presonal onset. So it becomes, in essence, this as a form of autosomal dominant AD, if you will. Of course, the inheritance is different, but the idea is the biology behind it is and the overproduction, a gene dose effect on the amyloid precursor protein. There was huge debate, and I think this is an area that needs a lot more research, also in homozygotes. But now, long prospective observational clinical studies, such as this one made in Ireland, that followed individuals for 17 years in this paper, clearly established that here the clinical penetrance, I'm talking this as an exception, is a clinical penetrance of the disease in Down syndrome is over 95%. And as late as last year, it was the first time that the Alzheimer's Association included that people with Down syndrome in the genetic forms of Alzheimer's disease at the same level as autosomal dominant AD. This is a huge step forward, and something that came, as you know, as you are seeing, very, very late. Until last year, the Alzheimer's Association criteria did not include Down syndrome in their criteria, because of the gaps they felt that we have been able to surmount with the research in the last few years. So, and this that comes from the editorial in the Lancet Neurology. What we argue is that there are 3 core characteristics for genetically determined AD. So first, you should have, and this should lead to near full penetrance, and I'll say that this is arguable too, but near full penetrance of the disease, that it should have a predictable symptom onset and a predictable sequence of AD biomarker changes. These are things that all these genetic forms usually have in common. And so first I'm gonna show AD is always the model, and what happens in Down syndrome, and of course then I'll move on to homozygotes. So what was the kind of evidence that we developed to support Down syndrome, to the reconceptualization of Down syndrome? First, as I said, things that we know that biologically the penetrance is full. By 40 years, we know in pathological studies they all have AD biology. In biomarker studies, as you will see, in the last 10 years, we've done tremendous advances in showing the penetrance of the biological penetrance, and in this case of Down syndrome, also the clinical penetrance is very, very large, almost near full penetrance. And this is another way to looking at it. It's like if you follow individuals, so you just imagine here, we are luckily in the APOE4 homozygotes are not at this, do not show this kind of risk clinically. Here you see, for instance, this is following people with Down syndrome that have no symptom whatsoever at the beginning of the study. I follow them for only 5 years. The red dots are those that are over 50 years of age. So if you follow 100 individuals or 1,000 individuals with Down syndrome over the age of 50 with no symptoms at the beginning, more than 50% will develop Alzheimer's, symptomatic Alzheimer's disease in 5 years. That's the risk they're facing. So that's why I'm saying that I'm very, very sensitive to the implications but I think we need to confront it. We really need to fight against this. So, what about predictability? Here we did a meta-analysis in which we analyzed the age at symptom at AD dementia diagnosis across all the studies that we could find in the last 30 years, mainly in Europe and the US. And as you can see, first thing is that even though we didn't have a harmonization on how to diagnose the disease, so everyone did as good as they could, you could see that all the studies, they really found like a very consistent age of symptom onset. And basically, as an individual with Down syndrome develops Alzheimer's at age 54, approximately. But as I came from the field of autosomal dominant AD, I thought that there was a dogma in the field of Down syndrome that didn't hold. And so we had this idea that Down syndrome was extremely variable with respect to the symptom onset. And that's because we've seen a lot of individuals with Down syndrome, age 45, 43, 48, that had AD dementia. And we also all that work with people with Down syndrome, we've seen individuals age 58 that did not have Alzheimer's. So the idea, the clinical impression that you have as a clinician is that this is very variable. But as I said, I came from the field of autosomal dominant AD. I did my PhD here, and I worked with them for several years in biomarker research.